Hi, my name is Sven Meyer. I'm from the Future Interfaces group at the Carnegie Mellon University. And today I'm going to talk about a paper which was accepted to CHI 2020 with the paper title Enhancing Mobile Voice Assistance with WorldGaze. The research I'm going to talk about today was carried out with my collaborators Gerard Lapoud and Chris Harrison. And with that, let's dive into the topic of mobile voice assistance. Today, each major smartphone manufacturer develops their own version of a voice assistant. Thus, we have voice assistants to our disposal at all time, right in our pocket. Today, we see three big competitors: Apple's Siri, Samsung's Bixby, and Google's voice assistant. They can help us with our daily tasks, such as adding and subtracting numbers, setting an alarm, giving us weather information, or even giving us opening hours for a specific restaurant. However, when looking closely, they all lack in fine-grained contextual information about the surroundings. In this example, when Siri gets asked about the opening hours for Starbucks, when standing right in front of the Starbucks, Siri shows a list of possible options for Starbucks surrounding the user. However, when the user is looking at the Starbucks, it is clear from an outside perspective that the user wants to know the information for this very specific Starbucks. Thus, this example makes clear that more contextual information about the user's inquiry is needed to form a coherent, well-defined question, which would make the assistant a way stronger companion in our daily lives. Thus, in the following, we look at possible ways to inquire more information about the user's surroundings, which then can enhance the user's voice inquiry, and finally make up for a more natural interaction between the user and the voice assistants. Looking at the device users are using to make inquiries to the voice assistants, it becomes clear that the back camera offers the perfect opportunity to retrieve more information about the user's surrounding. While the back camera offers an opportunity to understand the surroundings around the user better, it is not clear yet if the user is actually talking about what's displayed within the viewport of the camera. Thus, in a second step, by looking at the front camera, we can also retrieve the user's gaze vector. With WorldGaze, we combine those two features, the knowledge about the world and the knowledge about the user's gaze, to then extract where the user is actually looking at, retrieving the place or object, which then can be fed into a voice assistant, making a context-rich inquiry. Now, let's look at an example how this would work in real life. When walking downtown and looking for a place to grab a bite, but at the same time, we want to ensure that the place we go to has a good rating. In this case, as discussed, we want to enhance the mobile voice interaction, making it a context-aware inquiry. For this, we use the back camera to extract information about the world and the front camera to extract the gaze direction. Then, by knowing the intrinsics for both cameras, we can raycast the user's head gaze from the front camera into the space of the back camera, identifying the object or place the user is looking at. With today's voice assistants, we need to add this contextual information ourselves, either by giving it more verbal cues or even by interacting with the graphical user interface on the phone, selecting the right place. With WorldGaze, we implement a system where this extra contextual information is added to the inquiry automatically, making the overall experience more natural feeling to the user. But before we actually implemented WorldGaze, we wanted to know how such a system would feel to a user, how the user would react to such a system, and what we needed to consider when implementing WorldGaze. Therefore, we ran an exploration study in which we wizard of Oz WorldGaze, allowing us to understand how the user would react to the system. In detail, we wanted to know how voice assistants enhanced with WorldGaze would perform to alternatives to retrieve information we compared WorldGaze here to two alternative approaches. One was the traditional touch approach, and the second one was Siri as one of today's major voice assistants. In the touch approach, participants were asked to use Google Maps to retrieve information. For fair comparison, we used a boosted version of Siri, which actually knows which restaurant the user is talking about without asking the second question of which restaurant the user actually talks about. During the study, we asked participants to retrieve different informations from the surrounding restaurants, such as opening hours, rating, and phone numbers. After each of the three conditions, touch, voice, and WorldGaze, we asked participants to rate the system usability, the task load, and if they would use the system in the future. After completing all three conditions, we sat down with participants, interviewing them about their experience with using the three different types and how they compare to each other. The study was carried out with 12 participants, 9 male, 3 female, and the average age was 25 years. First, I'm going to present the results for our 3 different questionnaires. Looking at the results of the system usability scale, one might think that there might be an effect for the 3 different types. And indeed, a Friedman test actually revealed a statistically significant effect on the 3 different types. However, postdoc tests could not confirm this effect. Similarly, for the raw NASA TLX, we also conducted a Friedman test, which revealed a statistically significant difference for the main effects. In this case, post-hoc analysis revealed a statistically significant difference between voice and touch, positioning touch with the highest workload. Finally, for the question about possible future use of the system, there was no statistically significant difference for the 3 different types. While the quantitative analysis at first might picture a bad outcome for WorldGaze, our qualitative analysis definitely reveals a different picture. Here I want to quote 3 different participants. Participant 2 stated, "WorldGaze is faster, or it feels faster anyway, less frustrating." Another participant stated, "WorldGaze would be useful to have." And another one goes even further, stating, "Implicit input with WorldGaze would be striking." Thus, in summary, to conclude our exploration study, we argue that WorldGaze offers a lot of potential for future interaction paradigms. Thus, I want to take the remaining time to talk about use cases where WorldGaze can enhance future interactions with voice assistants. As already discussed in the motivation of this talk, WorldGaze can enhance interactions with voice assistants while being on the street. However, when interacting with large storefronts, one might argue that GPS could already help out to enhance their interaction. And while storefronts make a compelling argument to showcase the potential of WorldGaze, we actually think that when looking at smaller objects that we have even more potential. For instance, in the smart home environment, when interacting with lights, TVs, and thermostats, this can be real powerful as it can reduce the interaction with these devices down to a single keyword. Let's imagine the scenario in the upper left corner. Looking at the lights and bringing up the keyword on already tells the system the whole interaction you as a user want the system to perform, turning this very specific light on. Today, we need to go through apps on our mobile phones or through very complicated explanations to actually explain such a system which lights we would like to turn on. This not even gives context to the specific keyword, but also allows us to overload keywords, as the TV and the lights can be turned on with the same keyword. And the same is true for other keywords such as down, which can turn down the volume of the TV or turn down the thermostat's temperature. For this, we built a demo setup, of which I will play a clip next.
What's the temperature?
It's 23 degrees.
Down.
Setting to 21 degrees.
Down.
Setting volume to 70%.
WorldGaze can not only make smart home interactions easier and more natural, but also enhance scenarios like retail settings. Here the interaction can be enhanced by simply looking at an object and adding it to your wish list, asking for a specific color of a sofa in this instance, or even form complex questions in which the user is not only referencing one, but two objects at the same time.
How about the price difference between this and this?
The left armchair is $50 less.
In conclusion, today I presented WorldGaze to enhance mobile voice assistance. First, I presented our exploration study, which we built our implementation on. For the full details of our implementation, I refer you to our paper. And lastly, I presented how WorldGaze can not only enhance interactions on the street, but also in smart home environments and retail settings.